Dear students, today we are going to discuss polar representation of a complex number. You know that any point in a plane or in a Cartesian plane whose coordinates are xy, that is here p of xy is the point. Now clearly it represents the complex number z equals to x plus iota y, or if we have a complex number z equals to x plus iota y, then it is represented by the point whose coordinates are xy. Now if we assume that x and y is positive, that the point is this point here, it is represented, or it represents this z equals to x plus iota y, that is complex number. Now the distance of this point from the origin is mod of z, and you know that mod of z is root x square plus y square. That is the distance of this point from the origin. Now let's suppose that this mod z equals to r, that is r is root x square plus y square. Now when we draw two perpendicular, or when we draw a perpendicular PQ from P on x-axis, that is this here, we get the right angle triangle. Now let us assume that the angle which this is here the distance of, or the line is OP, that is line joining the point P, which represents the complex number to the origin. This is simply called as the position vector. Now if we assume that the angle of this line with the positive direction of x-axis is theta, then in right angle triangle OQP, base upon hypotenuse, here base is x, hypotenuse is mod of z, which we denote by r. It is cos theta, or x equals to r cos theta. Similarly, perpendicular upon base in same triangle, perpendicular upon hypotenuse, that is y upon r equals to sin theta, which implies that y equals to r sin theta. Now here x equals to r cos theta, y equals to r sin theta, and the given complex number is z equals to x plus iota y, which implies that z equals to, when on substituting x and y in given z equals to r cos theta plus iota r sin theta. Now r is common, taking r common, it is z equals to r cos theta plus iota sin theta. Now this is again complex number, because we have here iota. This form, or this form of complex number, is called as the polar form of a complex number, whose Cartesian or simple form is, or the general form is, z equals to x plus iota y. Here we have two parameters or variables in this one, or here this r is, we denoted this r equals to mod z. This means that r is here the magnitude, or simply we can say that the modulus of a complex number, that is r equals to root x square plus y square. Now the second variable is here theta. Now theta is the angle which the position vector of the given complex number makes with the positive direction of x-axis. Here we know that x equals to r cos theta, y equals to r sin theta. Now dividing y upon x, it is y upon x is r sin theta upon r cos theta. R cancels, it is simply tan theta, which implies that x upon y upon x is tan theta. Now theta is simply here tan inverse y upon x. Tan inverse y upon x. So here r is root of x square plus y square. Theta is here tan inverse y upon x. So if we have the Cartesian form of the complex number, we know the real part, we know the imaginary part, we can find its modulus, that is r equals to root x square plus y square, and this theta, which is simply tan inverse y upon x. Now this theta here in this polar form, it is called as the argument of a complex number. It is called argument of the complex number. In plane, suppose in here the value of the theta is between 0 and pi. In second interval, it is from 0 to pi. In third, 0 from 0 to 3 pi by 3 and in fourth we have the complete angle, that is 360 degree. So this means that here the value of this theta lies between 0 and 2 pi, because the complete angle is 360 degree. Now you know that when we measure the angle, we have two directions. One, the positive direction, that is the anti-clockwise direction, that is when we measure angle in this direction with the positive direction of x-axis. Here the direction of angle or the sign of angle is to be taken positive, while as if we measure the angle in the clockwise direction means in negative direction, that is here this clockwise direction in measuring the angle is taken to be negative. So we have two ways to represent the angle, or this theta is simply positive or negative, depends upon the direction in which we are measuring the angle with the positive direction of x-axis. So here we have a given plan, two axes, x-axis, y-axis. Now in this plan we have four quadrants, four equal parts, which are called as the quadrants. So in first and second quadrant, if we measure this theta in positive direction, means in anti-clockwise direction with the positive direction of x-axis, that is from up to this to this. So here the value of the theta lies between 0 and pi, while as in third and fourth quadrant, if we measure the angle from this to this in this direction, then its value lies between minus pi to 0, Now here, when theta belongs to minus pi to pi, then this theta is called as the principal argument, while as when theta belongs to 0 to 2 pi, then it is simply called as the argument of a complex number, So in four quadrants, in first quadrant like this, the value of the theta is simply 0 to 2 pi, so it is positive, it is again principal here in this. Now in second quadrant, that is if complex number lies in the second quadrant, the value of the theta is between 90 to this 180. So when it is 90 to 180, this means that it is in positive direction, this means that positive, hence it is again the principal value or the principal argument, because value of the principal argument lies between minus pi and pi. Here the value lies between 0 and 2 pi, 0 and pi. In third quadrant we have two conditions. Here in third quadrant we have two conditions. One, if we measure in anti-clockwise direction, means in positive direction. So when we measure the angle in the positive direction, that is in this direction, the value of this theta is greater than 180 degree. So if we consider this direction, then theta is simply called as the argument, but it is not the principal argument, because its value is greater than 180. While as if we measure the same, if we measure this same angle through clockwise direction, through negative direction, that is we are measuring the angle in this direction, this means that its value lies between 0 and minus pi, so when we measure angle in this direction, it becomes here the principal argument. Similarly in fourth quadrant, there are two ways to measure this angle. One, the anti-clockwise direction, means the positive direction. When we measure in this direction, here it becomes its measure is greater than 270 to 360, so it is simply here the argument. But here if we measure in this direction, that is here we have the complex number in the fourth quadrant, and if we measure in clockwise direction, means in negative direction, its value is something 0 to minus pi, when the value lies between 0 and minus pi, it is called as the principal argument. So simply we can say that for any complex number, the polar representation is z equals to r cos theta plus iota or sin theta. R is called as the argument, and its value is, R is called the modulus, its value is root x square plus y square, while as theta is called the argument, and its value is tan inverse y upon x. Now theta value of the theta lies between 0 and 2 pi. It is simply called as the argument of a complex number. While as when we consider the fixed values or the particular values and those values which belongs to interval minus pi to pi, then it is called as principal argument of the complex number. So thank you.